Okay. Assume average angular acceleration to be uniform, then we can reason out that omega has to be a linear function of t, so that on any time interval, average angular velocity is the initial plus the final angular velocity divided by 2. That's because it's linear. Now, we use that to do what? What do you want to do with the average angular velocity? Well, I think your impulse, and it's correct, and I'm not using impulse as the rate of change of momentum right now. You want to multiply the average angular velocity by the time interval to get the change in angular position, right? How can you justify that except by habit and memorization of formulas? Okay? You have the basic principle. Velocity is rate of change of position with respect to time, just like acceleration is rate of change of velocity with respect to time. That leads to what you know, that velocity is a derivative of position and acceleration is a derivative of velocity, or velocity is an integral, an antiderivative of acceleration, and position an antiderivative of velocity. You do that by habit, but you got to know where it comes from, okay? Again, otherwise there are situations where you're not going to be able to think them through so clearly. So, there's our definition, and the definition could apply to average velocity being the average rate of change of position with respect to time, or to angular velocity being the rate of change of angular, don't need the word angular there, of angular position with respect to time, or average angular velocity is average rate of change of angular position with respect to time. And it's the latter that we're going to use. And we do that, average angular velocity is a change in angular position divided by the change in clock time. Now, y'all have also mentioned all the relationships of graphs and slopes, and they're correct, okay? But we need to take it all back to the most basic definition. So, well, the change in average angular position is delta theta, right? Average angular velocity is omega bar, and the change in time is delta t, right? And now we can do our calculation, and we can base it on rigorous definitions, okay? So that's going to be what? Well, we average these two. It's and I wrote it out kind of small. It's 2.5 radians per second plus 2.1 radians per second divided by 2 multiplied by 10 seconds, right? And that's 23 radians, a little less than 4 complete revolutions. Okay? Do you agree? I mean, halfway between 2.1 and 2.5, certainly 2.3, so I don't really have to add those and divide. But I would probably want to, 4.6 divided by 2 is 2.3. And multiply that by 10 seconds, and I get 223 radians per second multiplied by seconds is radians, okay? Now, this is how we take this situation, take it back to the most fundamental level, okay? Because I want you to be able to build everything by next week from the most fundamental level. And I'm going to want you to show me how you build it from the most fundamental level. Doesn't mean I won't, on some problems, ask you something that I allow you to use equations or integrals or whatever you want to use. But there will be questions where I give you information that doesn't require those things. Okay? I could also ask you to take these two definitions and derive the equations of motion. Uniformly accelerated motion. Very easily done. Okay? And we'll probably talk about it. We've already pretty much done it when we drew a velocity versus time trapezoid. Calculated the slope and the area and interpreted them. Okay. So, this is how we do things based on definitions, and we develop a better intuition about what velocity, acceleration are and how they're related to position and one another, okay? We develop an intuitive understanding rather than an equation understanding, a formula understanding, okay? The homework that I've looked at looks pretty good with formula understanding, okay? And that's what I'd expect, since most of the class is taking dynamics where you use these formulas, okay? But I want to pull you away from the formulas toward meanings, okay? Not that you don't have a good idea of a lot of meanings, not that you don't have a good idea of these relationships, but we want to build everything from the fundamentals.